Welcome to Chapter 3 of our Unity project where we're going to make an FPS. So in this chapter, we want to put some enemies into our game. And so we've got weapons, different weapons to attack with, and we just need something to fight. And so that's going to be some robots. So let's start with, well, I guess I'm going to point this out. This arrow right here, I have trouble tracking that thing down, but a lot of times if you just reset your layouts, if you just maybe tell it to go back to the default, you can kind of get that error to go away. As you can see, I don't have it again. Anyway, so what I was going to say is we want to start by importing some of the assets into our project. And I'm going to continue using the Unity's tutorial for their FPS because I think they're just good assets. So we're going to, I'm going to update the original package, but just to make sure, I'm going to re-import this. This is the Unity FPS things. You can also download their asset package and use it that way. But this version, I've stripped out all of their scripts because I want to write the scripts from scratch so that we can kind of get some of the practice building some basics here. So as you can see, everything here that's about to be imported is just, and it's not importing these because I've already got some of them, but it is importing in different enemies and different projectiles. So I might need to be careful with this here. You see how it wants to replace the blaster and the disc. I actually don't want to do that because I've modified them when we were making our project. So be careful with these ones that have these arrows, because then also the weapons, I don't want to re-import the weapons because we spent a lot of time setting up some scripts on them. So just kind of keep an eye on it. Make sure that you do not import the ones that have these arrows. We don't want to update those. We only want the things that are new. So then we import it. And just to make sure everything's still okay, when I hit play, all of my weapons are still fine. But be very careful on that step because you could accidentally destroy some of your hard work. And I don't know if you can undo that. I don't think you can. So I've actually put it in, some of the stuff shows up inside the Unity FPS folder here. So I'm going to move some of this over there. Just so that I'm a little bit more consistent. Ooh. Wonder why the art is currently saying cannot be moved. Well, I don't need to worry about that right now. That's a me problem. I probably have one of the files open somewhere on my system. So that's fine. I'll just do that kind of offline in between videos. So we should have new prefabs. When we imported it, in addition to our, we had the weapons prefab, we had the projectiles, I think we had the visual effects, but now we should have some enemies. And I want to work with the Hoverbot. We could play around with the enemy turret as well. So let's take a Hoverbot and place it in the world. And you can see that it does have like a ton of like particles and gizmos and such attached to it. By putting it into the world, it should have dropped the collider at about the correct height. But it's not going to do anything right now. So like if we go look at it, it's just going to be hanging out there. It's actually playing its default idle animation. And in one of the later videos, we'll look at trying to trigger some of its other pre-built animations and setting up the animator for it. But in this video, I just want to get basic movement working. All right, so looking at this, I've already included the Nav Mesh agent, and that's going to be the movement system that we're going to use. Essentially, the Nav Mesh, we can any walkable surface, we can put a nav surface on, and the Nav Mesh agent will be able to essentially use Unity's pathfinding to walk on it. And that's how we're going to handle movement so that it doesn't like teleport up walls or teleport through walls. So you might have to click on this install AI navigation package if you see that button there. And that's just going to add in the required Unity backend stuff. We won't even notice it, that it's going to be there. Well, I guess we'll notice the little navigation thing that popped up there. But that this allows us to make use of the nav components. So if we look at all this, you can create extra versions of what agents there are. And I'm just using the default of humanoid. And this adjusts how fast it moves, how fast it can turn, how quickly it stops, and just some issues. This is like this movement settings. And so we end up not setting that in our script that we're going to write. We're going to set the nav target via code, but we're not going to really adjust the speed through code too terribly much. So now that we have the Nav Mesh agent, we do need to attach a nav surface to anything that we want this this character to walk on. So I'll want this terrain to have a Nav Mesh surface. So what we've got to do, I think it might be in the components. So, actually, there it is. Navigation, Nav Mesh surface. And so while we have terrain selected, if we attach the surface, we can now determine what is walkable, like what angle we're allowed to walk at. So like you can take a look at all the different constraints. We could take a look at the humanoid settings. I think the humanoid settings was over on the Hoverbot. Oh no, they're actually somewhere else. Yeah. So this controls like how much of a slope can it go up, how much of a step can it climb, and other just things. So you could play with this. If you're going to have an extremely large enemy, you'd want the radius to be bigger. So adjust these as needed, but I think they're pretty self-explanatory in terms of what they do. Anyway, so once we've attached this, we're going to have to kind of make the ground look ugly temporarily. We're going to need to tell it to calculate the walkable area, and that is done by clicking the bake button. This is going to generate the walkable area on my terrain. So we can click it. I mean, it might take a second or two, depending on how complex your ground is. And you can see that it puts this this blue thing over everything, and that is what it can walk on. Now, it does kind of create a few shenanigans, like the fact that these blocks are pushable, but they're not part of the nav mesh because it doesn't generate this dynamically. And so you would probably need to play around with some of the settings to get it so that it would ignore those blocks. But let's not worry about like dynamic nav meshes at the moment. So we've got a nav mesh. And if that drives you nuts, you can always turn it off right there. That way you don't have to see it, but we know that it's there because it says that the nav mesh is assigned. So anything you want the character to walk on, you would need. Now, we didn't add any scripts yet, so nothing really has changed. You know, the enemy's still going to hang out there. Not going to move because we haven't programmed any sort of movement logic. And so let's start doing that, because that's going to be the powerful part. So let's go to our scripts, and I'm going to make a new folder for enemy stuff. So I'm just going to call this enemies. And inside of here, I'm going to create a new C# script called enemy. This is going to serve as the parent script that when I start making more specific like child scripts, I'll make this the parent. But this is going to be the vast majority of our enemies' behaviors. So let's double click it. And now we can begin coding some of this stuff. I'm going to take out void start and void update. I'll add them as needed. So what I want to achieve in this video is I want to get movement. And so movement's going to require us to have what's called an aggro radius. So we need to determine at what range is this thing going to become hostile to the player. So that's what this variable aggro radius is going to be. Let's just set it to 12. While I'm setting these up, I'll set an attack radius, and we'll call this attack. Sound like, I guess I'll just call it. I'm struggling with what name I should use here. Ranged attack radius. This is the point at which it's eligible to fire at the player. We'll do 5. And then we'll do one more for a stop distance. Once it achieves this distance to the player, it will stop chasing us. So it doesn't run up into our face and continue to push into us. Because this robot isn't going to have a melee attack. So we want it to just shoot us with like a blaster. So it's going to get close to us, but it's going to stop at a certain point because it's not going to try to get next to us. And then I am going to use a show debug variable so we can draw these radii so that we can actually see them inside of the editor. So we get an idea of how big 12 actually is. Like, what does that mean? So now for some of the useful internal variables. It's worth remembering our start position. I'll set it to 0 for now. We want a movement target. Now, I switched this to the visibility protected. Protected is like private, but children classes can see it. And that's because I'm kind of planning ahead, and I think I'm going to use this as a parent class eventually, so I'll be inheriting from here. And so I want the children classes to be able to see that and have access to it. So I'm also going to do that with the Nav Mesh agent. And I'm going to also make a reference to the player so that I don't have to continue finding the player. If I find the player once, I'll be happy with that. So let's work on the awake method. So when this thing wakes up, we want to attach a few things. So we want to attach the Nav Mesh agent. So agent equals get component, so pretty standard. Then we want to remember the starting position. So that way, if it chases the player, it will go back to, we can use this as the position to go back to where it came from. Now, movement target is going to be an important variable. Movement target is going to be where this thing wants to go. So we'll set the movement target to the start just for now. And if we detect a player, we'll move. So we'll just say movement target equals start position. So when this thing wakes up, when the game loads, it will want to travel to its start position, which it already should be there. And we'll attempt to find the player. So we'll say player equals game object dot find game object with tag player. Now, I don't know if we've tagged player, so we're going to go need to do that. And I will say that this might be kind of risky in the sense that this may not work. So we might also have to search for the player like on a per frame basis, because the player isn't in the world when the world loads. If we recall, the player gets spawned by the game manager once the level loads. The player isn't in my hierarchy, so when the level immediately, that very first frame when the level loads, player's not going to be in the world, so this may fail. Just kind of pointing that out. So let's go tag the player real quick. So that's going to take us to the prefab for the player. And as you can see, we haven't tagged it yet. So let's switch the tag over here to player. That way it's easy for us to find for the AI. So returning to our script, what we're going to need to do is have this thing determine where it wants to go. And that's going to be where a lot of our logic is going to play in. So let's bring back the update method. And I'm going to break off each like individual component into a separate method. So essentially what I want to do inside of update is decide where to go. Then I want to set the nav mesh agent to that target. And we'll fill that in as we go. And then eventually we'll figure out attacks. So we'll figure out attacking after all that. But that's basically the flow of my update method. Decide where to go and actually set where to go as my target to movement. So let's work on a method to figure out where we want to go. And all of these methods could end up becoming complicated, which is why I'm already making them separate methods just to compartmentalize them away from putting this all inside the update. We can just call decide movement right here. We can just do that right now. So we run that. And also that can set up polymorphic behavior in the child if we want to update how it decides its movement independently. Then update will still call the overridden version. So first up, we want to calculate the distance to the player. So that's kind of like our first step of deciding where we want to go. We want to see if the player's close enough to bother with. Now, we're setting a default. And this is so that I'm doing this to protect against issues if the player's not in the level for whatever reason. As we know, like the first frame, the player may not be in the level. So we need to be careful about that. So we want to set it, we want to assume that if the player is not in the level, that we have like an infinite distance to the player. That seems reasonable. And we will say that the player position, it doesn't really matter at this point. So we'll just say just a regular new vector 3. So we're just going to set it to a 0 vector. So we don't know that, like, these will hold the actual position of the player, but right now we don't know if there's even a player in the game. So let's say if they're so if player is null, meaning we didn't have a player, like assuming this line failed, let's try it again. So we will attempt to find the player. Then if we found the player, update the distance and position. So if player is not equal to null, meaning we actually found a player in the world, then we will do player position equals player.transform.position. The autocomplete is pretty intelligent here. And then we want to calculate the distance to the player. And the autocomplete is wrong here. We'll use the vector3 distance method from the current position, so from the enemy's current position to the player's position. And so we will update this distance here. So now we've gotten a position of the player and we've got a distance to the player. So now we can start making decisions based on how far the player is away from us. So that's where we're going to go next. So this is the movement AI decision-making part. The first part, we're just really kind of crunching some numbers, figuring out where the player is, and now we're going to actually make some decisions and set some movement targets for this creature. So first up, if the player is within the aggro radius, then we want to chase the player. So if distance to player is less than or equal to the aggro radius, then we want to chase the player. So movement target equals player position. However, if we're close enough, and that's that stop distance variable, then stop moving. So we will say if distance to player is less than or equal to the stop distance, then we'll use agent dot is stopped true, and this will stop it. Just kind of freezes the agent there. Otherwise, we will re-engage it. Now, if we wanted to get really fancy, I suppose if we were too close to the player, we would recalculate a new position that's like away, so the robot would move away from the player. But I want to keep this kind of simple. I don't want to go down too much of a crazy rabbit hole of stuff. So now the other case is if the player is too far away. So if the player leaves the aggro radius, we want to return back to the start. So we would just say that our movement target is the start position. And then make sure that agent.isStopped is false. So that we make sure that the agent will move, that it's not going to sit there kind of just chilling. And so that's our code for deciding the movement. Let's put some comments here because this is actually a pretty long method. All right. So let's we call the method. Now let's set the nav mesh agent. So we can say agent dot set destination movement target, and this should get movement to work. It should be a pretty straightforward affair of actually chasing us down. So let's hit save on the script, and then we'll want to attach it to this enemy hoverbot here. So we could take that, drag and drop it on, and you can see that that shows up right here. All right, so let's see if it chases us. So our robot is hanging out all the way back there. So as I get closer to it, you can see that it's actually starting to move towards me. Now I feel like the closeness might be, something might be wrong with that. It doesn't seem to be wanting to stop. So we'll play around with that in a second. But let's get some gizmos set up on here so we can see what that stop distance even is, to make sure that it is going to stop there. So going back to the script, kind of giving this a quick read over. If distance to player is less than or equal to stop distance, oh yeah, that should work. And stop the agent. Yeah, that's weird. So let's at least get it to show us some gizmos. So we're gonna do on draw gizmos, and this is only if we have the show debug thing checked. And I want to show my different gizmos. So let's say gizmos.color, and we'll use yellow. This is for the aggro radius. If the player is within this radius, the enemy will chase us. So gizmos.draw wire sphere at the transform.position, so basically the creature's position, size of aggro radius. Now we're going to repeat this for the attack radius, which we haven't done attacks yet. That'll be the next video. And that'll be magenta. And then we will do the stop distance. So this is the one that isn't working right. So we'll be able to figure this out. So if we're within this red thing, let's hit save on that. And the only other thing I could think here, maybe if the player distance to player is less than the stop distance, what we could do is have this debug and print out the player distance, so we could see like why that might not be triggering, why 2 might not be working. All right, so we can see these radiuses now. These are the distance at which the enemy will begin to chase us at. I guess I can just turn the gizmos on here. All right, that's some quality wire spheres. All right, so we go into here, we get into this sphere, and it starts chasing us I guess maybe I need to make that stop a little bit bigger, because it seemed to be a momentum issue. So let's maybe bump its stop up to 4. And we should see that it might, yeah, it stopped more appropriately there. You can actually see like our nav mesh, like its target gizmo. So if I run really fast, we should see that target go back to its spawn point. And you can see that it does like correctly path around things. Now, oh, I think it is going to have some pathing issues. Like it may not really recognize what a door is because those doors were blocking this when we baked the nav mesh. So we're not going to worry too much about that. That'd be a little bit more advanced stuff to play with. But instead, we've got an enemy that's capable of chasing us, and it goes back whenever we escape its aggro range. And so this is a really good start for a relatively simple enemy. And so in the next video, we'll play around with getting it to attack us, and so that we can have it shoot some lasers. I might make its attack distance further because this is like basically shooting point blank at us. It'll be really hard to dodge those shots. But so yeah, that gets a basic enemy moving. We'll play around with getting some attacking and getting some of its different animations working in the next videos. So thanks for watching, and I will see you in our next enemy video.